in the mid to late 80s, a group of people got together, one of which was Dr. Shoup, Paul, he's a friend of mine. And at that time, NASA was just ending their SETI program. The government pulled out of SETI. They ended it. They decided it was a big waste of taxpayer money, so they decided that we were going to just end it. And at that time, Dr. Shoup got together with a couple of other gentlemen, and they formed the SETI League, and they decided, hey, if the government's not going to do it, we're going to do our own. We'll take it private. So, as a matter of fact, virtually nowhere in the world is any government doing any government-sponsored SETI research right now. And we're talking about searching for extraterrestrial intelligence. But before we can get to searching for intelligence, we need to talk about searching for life among the stars. And this is the overarching theme for SETI, is searching for life everywhere, wherever we can find it. Bear in mind that there is only one place in the universe right now where we know that life as we know it exists. That's right here on Earth. So we're searching for life among the stars, and we're searching for life as we know it. Can anybody guess as to why we don't search for life as we don't know it? Everybody asks me this question. Well, you always talk about life as we know it. What about life as we don't know it? Well, we don't know what to look for. As a matter of fact, biology is still a very dynamic science because we can't even decide what exactly life is down here on Earth. So how are we going to figure out how it is elsewhere, in addition to trying to figure out how it's not elsewhere? So we can only look for life as we know it. We need to look for carbon-based life, and we need to look for life as we know it. So we search for life among the stars, and the question that we've always asked is, are we alone? Are we alone in space? Are we alone in the universe? Are we the only, is this the only life here? Is this it? Or is there life elsewhere? And of course, if you ask an alien, they say, no, of course you're not alone. But we haven't found any aliens to ask yet, so we can't actually ask that question. To get into how we do SETI, SETI is the radio search for extraterrestrial intelligence. And to get to that, first we need to look at the birth of radio astronomy, because SETI would not be possible without radio astronomy itself. And radio astronomy first began back in 1932 with Carl Jansky. That's him in the foreground in that little picture, if you can see it. And in back of him is what he's named the Bruce Array. And that whole thing swivels around on a track looking up at the sky. And what he did was, what he found was when he looked at the sky, no matter where he turned that antenna, he heard static. He heard cosmic static. All right? So then we go on. Let me make sure I know where I am right now. So that's Carl Jansky. And next up is Reber, another ham, W9GFZ. Anybody recognize that call sign? Who's seen the movie Contact?
Yeah.
In the beginning of the movie, little Ellie is sitting there at her ham radio station, and she's going, W9GFZ, W9GFZ. That's the call sign she's calling. He built the first 10 meter diameter dish. Rick, what's 10 feet in 10 meters in feet?
33, 32.
It's big. It's big. It was the first true radio telescope in that it could be pointed in any direction in the sky. I asked Rick because Rick is resistant to using the metric system, so I thought I'd just pick it. I know, you're going to get me for that later, right? He also developed the first map of the Milky Way galaxy in which we are in. Now we start getting into real SETI. Frank Drake is the father of SETI. He was a radio astronomer. He worked at Green Bank, West Virginia in 1960. He decided on his off time when his boss wasn't around, he'd take this large dish and he targeted two sun-like stars, and he listened. He didn't hear anything, but he wanted to carry out the experiment, and he thought that the experiment should even go further. So he organized a meeting of like-minded scientists, and that meeting was the Order of the Dolphin. I'm sorry? Oh. So the Order of the Dolphin was a meeting of like-minded scientists like Frank Drake who realized that the probability of there being life elsewhere in the universe was just, there has to be somebody else out there, because if you look at the Milky Way galaxy, and there's a model of it in the background of the photo there, it's 100,000 light years across in diameter, from one edge of the disk to the other edge of the disk. 100,000 light years. There's somewhere on the order of 250 billion stars, plus or minus about 150 billion. So there's a whole lot of stars out there, and as Ellie would say in Contact, if there isn't other life out there, then it's a big waste of space. And we kind of agree that the odds that we're alone in the universe seem to be astronomically large. I mean, seem to be pretty low. It seems that there must be some other life out there. I actually went there. I took this picture. This is the Green Bank Telescope in West Virginia at the National Radio Astronomy Center there. And I used to be in the foreground of the picture with my wife. She decided to divorce me last year, so I tried to take her out, but I messed up and I took us both out, so I just figured I'd just leave it alone, you know. But that thing is big. It's 100 meters across. It's 10 times the size of the one I showed you that Grote Reber made. It's 100 meters across. Do I have that right? It's 100 feet. No, I'm sorry. It's 100 meters. It's 392 feet in diameter. And that was built after the dish that I showed you that Frank Drake used, because it was destroyed in a storm. So they built this to replace that antenna. At the meeting of the Dolphin, Frank Drake decided that he needed to make up some notes, kind of like I'm using right here. I have a notepad here that says, okay, say this, say that, and the other thing. He did the same thing, except being an astronomer and a mathematician, he put it in the form of a mathematical formula. And it's become known as the Drake equation. Now, bear in mind that this equation was never meant to actually produce any real numbers, but it was simply to keep the flow going of the conference. But be that as it may, plenty of people have actually taken this equation and tried to relate that into actual numbers of civilizations that might be in the galaxy, and see how many people that might be out there, other beings that might be out there that we could contact. So, starting from your left to right, the letter N is the number of civilizations in our galaxy with which we might communicate. And he set that equal to our star, which is the average rate of star formation, multiplied that by the fraction of those stars that form that might have planets. And then you get to NE, N sub E, which is the average number of planets per star that could support life. Then you get to F, and you multiply that by F sub L, which is the fraction of planets that could support life that actually develop life. And then you multiply that times the fraction, which is F sub I, that actually, you see how this is going. It's all drawn out. But if you plug in, for example, if you plug in the number 1 for our star, somewhere between 0.2 and 0.5 for the second fraction of our stars with planets, and about 1 to 5 for NE, and then all the rest of those fractions are all guesses, because we have no idea. We know how many stars usually form in the Milky Way galaxy. We know how many, we're starting to get a handle on how many of them actually have planets. And we're starting to get a handle on how many of them possibly could support life. But after that, everything else is a guess. So if you put in just the number 1 for F sub L, F sub I, put in a fraction of like 0.2 for F sub C, and then 1 to 10 billion for L, which is the length of time that F sub C actually released detectable signals, after which time we figured that they've probably killed themselves off or some kind of natural disaster has happened. Okay? And when I say that, we're in our technological infancy right now. We're still a warlike species. We're at war with everybody. Everybody on Earth is at war with everybody. There's all kinds of stuff going on down here. Everybody's worried about where things are going to be going. So we don't even know how much longer we'll be on this planet. So far, man has been around for just about 1.5 million years, which is about the average lifespan for an average species on this planet. So we could be getting close to the end, or maybe because we're so smart, we've got these huge brains which nobody else has, no other species on our planet has, maybe we might overcome our infancy and actually move on and last for a much longer time. We don't know. We're all working on it, right? We don't want that to happen, right? We would like to all stay around for a while, right? Raise your hands if you agree. Yeah, thank you.
Well, somebody got more time than others.
Yeah. But don't worry, Walt, you're going to be around for a long time. All right, so that's how Frank Drake laid out his meeting. And so this happens to be the ditch at Joe Drill Bank in England. It's another very large dish. I don't even know the size. It's not quite as large as the previous dish that I just showed you. And then
It's a radio telescope?
it's a radio telescope. I'm sorry, Walt. Yes, you're right. It's a radio
I
telescope.
wasn't here at the beginning, sorry.
That's all right. We'll catch you up. We'll catch up as we go along. There's also a graph there that shows, if you look at the bottom line there, the x-axis, it goes from 0 hertz to 1 terahertz. Basically, it goes from DC to daylight. Okay, and on the vertical axis shows the average the temperature of the universe at each one of those frequencies. And in radio astronomy, everything's done in temperature. So we measure everything in temperature, not in decibels or anything like that, like we would use here in this group. So that's sort of just caught on and stayed with the SETI community.
Temperature in Kelvin?
I'm sorry?
Temperature in Kelvin?
Yes, temperature. I'm sorry, you can't see that back there. Yes. It starts at 10 Kelvin, goes up to 100 Kelvin in the middle, and the top is 1,000 Kelvin. Okay, and that's degrees. Kelvin's not degrees. It's just Kelvin. And if you look at
How much is a Kelvin increment?
Let me get back to you on that. Let me take the questions at the end so I can get through these slides, okay? If you don't mind. So if you look at this graph, everything from 1 gigahertz down, that means HF, we know how noisy HF is, especially right now. And from HF all the way up to about 1 gigahertz, it gets kind of noisy, but the noise level starts to drop right as you get just past 1 gigahertz. And just over 1 gigahertz at a frequency of about 1420 megahertz, we call it the hydrogen line. it gets nice and quiet and we can listen and we can hear stuff. It also means that radio communications coming towards us from outside can get through our atmosphere. And as you go further down the graph, we get to another line here. It's called the hydroxyl line, OH. And that's at about 1600 megahertz. We call this the water hole because if you add H and OH, you get H2O, that's water. And we figure, just like in the past, the African savanna, all the animals would be meeting at the water hole. So we figure if someone's transmitting or listening, that's where they might be listening if they have a planet with a similar atmosphere and similar conditions. So that's why we focus our attention there, because those are the frequencies that can get through the atmosphere. Those are the frequencies, those frequencies themselves are protected. They're for radio astronomy only. So there should be nobody transmitting on there at all. So that's why we concentrate our effort there. Now, doing that, we're limited because we're only looking at perhaps the 0.1% of the radio spectrum. But it's the percentage of the spectrum that can actually make it through the atmosphere. Then as you go further down the line, further up towards 10 gigahertz, 100 gigahertz, then the noise starts picking up again. So we want to stay right in that area when we're listening for ET. There we go. Oh, I pushed the wrong button. All right. So there's been quite a few programs that started. Right about the same time as Frank Drake was starting his experiments, John Krause at Ohio State University decided to start building his own project. And it's called Big Ear. And this was built on an unused football field at Ohio State University. And it's a very, very big array. It's called the Big Ear Array. And it was actually collecting data for quite a long time until right about 1977, something was heard. And that's the printout that they were getting at the time. They didn't have any fancy waterfall displays or anything like we have today. They got these printouts. And these numbers here that are circled represent the signal down here. And the technician that was monitoring at the time, his name was Jerry Emmon, and he wrote, "Wow," in the margin, because he'd never seen a signal like that before. And if you take that signal and transform it into something that's more recognizable, you get a graph that looks like this, with this huge peak, way above the noise, way out of the noise, not in the noise at all. It's just, it's out there like a sore thumb. It's right in the microwave window that we're looking at, right around 1420 megahertz. And that signal there is what started everything off. Because for years after that, we kept going, where did it come from? Who was it? Do we know what the source was? Can we say that this is ET? No, we can't say it's ET because one thing, scientists are very particular. In order to be able to make reasonable assumptions about something, it has to be repeatable. If it's not repeatable, it's just a fluke, it's something that just happened, it's just a random thing. So it has to be repeatable. We're looking for signals that are non-terrestrial in origin. So again, no one's supposed to be transmitting at that frequency on Earth. So if no one on Earth is transmitting there, it has to be up there, right? Yeah, turn up the amplifier. It must be repeatable, and it has to be observable by other people. It has to be independently confirmed. This is the part, what I'm just talking to you about right now, is the part that sets SETI as a science as opposed to people who look for UFOs. And I don't want to discredit anybody who likes to hunt UFOs. It's fun to watch them on TV. But they haven't come up with any real proof either. They've come up with about as much evidence as we've come up with, which is 0 so far. That doesn't mean that ET is not whizzing through the atmosphere in flying saucers. It just means we haven't had enough people actually see it and actually, I mean, they're saying that there are alien bodies stored in Area 51. Well, drag them out here. I want to see them. I want to take samples. I want to do some tests on them. I want to see them. If we can't, then it's not going to help. Now, this signal, the WOW signal, remained a mystery for over 42 years. And it's still somewhat of a mystery today. But just recently, I read about a group of astronomers that have been digging through data and realized that at that time, at just about that time, there was a comet that was going through our solar system that we didn't know about. And it was a water comet, and it could very possibly came from that. Either maybe it was giving off natural hydrogen emissions, or because hydrogen, the reason why we look at the frequency, the reason why that line is called the hydrogen line is because every million years or so, the electron around one of the hydrogen atom flips and starts going back in the opposite direction, and that gives off a radio signal that we can detect. So we thought maybe that was happening in that comet. Some others have thought, well, maybe also ET could have been hiding inside the comet and transmitting to us as it was on its way by. Maybe that was their spaceship. I don't know about that part. But it seems like maybe that this might be the answer to our mystery of the signal. Get myself straight here. And we're also looking for planets that might possibly bear life. This is Jerry Amon. He's the one that discovered the WOW signal, and he's still involved heavily in SETI research. Now, on these extrasolar planets that we're showing here, kind of looks like our solar system, could be any solar system. We're looking for planets that have stable orbits, somewhere in the Goldilocks zone, somewhere where it's not too hot, not too cold, but just right. That's why we call it the Goldilocks zone. And we're looking for planets that have rocky shores because life needs to be able to come up out of the ocean in order to develop intelligence, and not just intelligence, but tool-making abilities. Dolphins, the reason why the order of the dolphin was called that is because dolphins have brains just about as large as ours, but since they live largely in the water, they don't have the ability to develop technology and manipulate tools and materials that we have. So dolphins might be every bit as intelligent as us, but they can't develop technology, and they certainly can't develop radios and electronics down in the water because they'll get electrocuted. Especially if they have the big amp on.
But they can't thank us for the fish.
Yeah, I like the fish. We're looking for planets that have nitrogen skies because that's a dead giveaway that there might be life on that planet. Might be worth investigating. Liquid water. The saying is follow the water. We always want to follow the water. Wherever there's water, we believe there's life, or the capability of forming life. Now, our planet actually killed off life a couple of, like 4 or 5 times in its history. All life was extinguished on the planet early on. But because there's water on our planet and because the conditions seem to be just right, it seems that after every natural disaster that has wiped out all life on the planet, life seems to want to start up again. It's like every time the conditions are right, life just wants to start. How, why, maybe God did it, we don't know. But But that's what it seems to be, that just no matter what you do, life will always find a way, as they say in Jurassic Park. Life will find a way to arise. And sometimes it could be a hoax, like maybe old cavemen who've been drawing on the caves and maybe imbibing a little bit of holy water. And one decides, oh, I wish I could be there when they discover this one. And he drew a picture of an alien on the wall. And we have other hoaxes that arise from time to time. This is from one of the tabloids. Proof of life on other planets. Human forms found in a meteor. Well, we've never found human forms inside any meteors, but these guys seem to think that we did. But we have found meteors that hit the ground, meteorites on Earth, that seem to have what look like microbes in them. Here, and all these little specks here. Those look like there might be microbial life. The unfortunate part about this is that most meteorites, after they've hit the ground, they usually stay there or get buried under the earth, buried under ice. This one was found in the Arctic, buried under a couple of tons of ice. The problem is that once it's been on Earth, that it has the possibility of becoming contaminated with Earth bacteria. So we don't really know if those microbial forms, first of all, are they really microbial leftovers? And did they come from here on Earth, or were they transported from? So again, we don't have enough evidence to say that there is life out there. Or if there's intelligent life. This is a fossil of a trilobite that lived approximately 250 million years ago on Earth. And we don't have any evidence that it was intelligent, although we don't know. That's what we say over and over again. We don't know. We don't know yet. So what is it going to take to actually carry out this search? And here's the part where radio amateurs can get involved, especially those who are involved in moon bounce, or EME. Because those amateurs who already have all that stuff set up already have the ability to do this. And especially if the moon is not over the horizon, you could be sitting there listening for ET. Why not? It used to take facilities that only governments, in fact, not even governments, but collections of governments could afford. But here's a picture of Dr. Schuch, Paul Schuch, again, N6TX, and he came up with the idea of a new paradigm, SETI with what you could afford, with what we could afford. And we started a national grassroots nonprofit organization. This is one of the SETI League meetings. I was actually at this one, and I think I was in this chair over here, and I think I went to the bathroom at that time that they took the picture. So I didn't make the picture.
Empty chair.
What's that?
Empty chair.
I got to take nature calls, right? So the basic idea of setting up a SETI station of your own involves a large dish, preferably somewhere around 10 to 15 feet in diameter, like the old TVRO dishes that we had, just like our friend Ken, N4HYV, has listed on the pre-net, the 1815 SWAT net. He's got one that he wants to give away. Just come and take it. Just come and take it. He doesn't want to set up his own SETI station. I've talked to him about it. He's not interested in that, and I understand that. But this dish is available here in St. Pete. Get a feed horn, a small antenna for 14, 20 megahertz, pipe it into your radio, Now, the radios that we started out with back then was either the ICOM IC7000 or the 7100. Today, we're doing all SDR. So we've gotten away from that because it was a very expensive radio. I paid $700 for one that was used. So it was a very expensive piece of equipment. Not to mention the computer that you pipe the audio into, and on that computer you're running software that shows the spectrum, the audio spectrum from the radio. So not only are we looking at a very small slice of the radio spectrum at 1420 megahertz, but we're looking at a very small slice of the audio portion of what we're listening to. So at that time, we were limited to receiving somewhere around 300 hertz. So if we were to integrate that out to one channel, to 1 hertz per channel, we can get 300 channels that way, 3,000 channels that way. Now this project was called Project Argus, after the Greek god, Greek guard god that had 100 eyes. But we were looking to get 5,000 eyes, 5,000 small dishes spread out across the globe, coordinated over the internet, and looking in all directions all at once. And there's a map of some of the stations that we used to have set up. They mostly are concentrated around the mid-latitude, some are on the equator, some are down on the other side of the world, down under. And we also had our own array that never realized this was never realized to this extent. This is an artist's conception of it. We actually only had four dishes that were implemented at the time. I think it's still there. It was in New Jersey. It was on the New Jersey-Pennsylvania line on the property of N6TX. It's still there. He's still there. So I imagine he's still listening even now when we're talking. This is my dish. This is an 8-foot dish that I got for free from the state of Connecticut. It was sitting in one of the parking lots. It was part of one of their microwave relay systems that they had set up for emergency communications around the state, and it was defunded quite a while ago. It had been sitting there for about 10 years when I found it, and they gave it to me for free. They just said, "Take it, come and take it." So I did, and I set it up on my property. In the back is not a football goal post, but that's my 440 megahertz system that I was also using for radio astronomy. We heard a few things. We still didn't know what this was, but it was a signal that was received on my setup. I've also received GPS interference and other satellites. L2 is a satellite. I live close to an airport, so I got air traffic control radio interference all the time. You can tell that it's terrestrial traffic, it's terrestrial radar that's sitting there, because all the lines are all going up and down. There's no slant to them. The slant shows, if you look at the one on this slant shows that whatever object this was, the satellite, was actually moving. So just like the Doppler effect, when you hear a train whistle coming and you're standing by the side of the track and you hear it start, it does the same thing here, except it shows it on the waterfall. Moon bounce. The SETI League has their own moon bounce beacon. It hasn't been operational in the last few years, but we've actually helped to calibrate systems at Arecibo and in Green Bank and Jodrell Bank over in England. So it used to be available whenever the moon was over the horizon in New Jersey, And a lot of amateurs were able to receive this. Iridium satellites. Supernova remnants, this is one of my friends, Marcus Leach up in Canada. He charted this one. I'm not sure where it was. He didn't write it on his chart. A group of amateurs also decided to listen for Mars Global Surveyor, which they did. They got it, and that's a picture of it. Now, one of the things, if you can't set up your own SETI station at home, there are things that you can do. One of them is SETI at Home, which is the program that you can download onto your computer and have it, when you're not using your computer, it will take over and start doing calculations on data that was received from either one or more different radio astronomy locations around the world. Mostly from Arecibo, although that one was damaged severely by the, what was the hurricane that went through there? Maria, thank you. And it still hasn't gotten quite operational yet. Large facilities, hate to see that go to waste. But SETI at Home, you could actually, sorry, no. SETI at Home, you could actually be crunching numbers for somebody else. Myself, I actually like to look for my own evidence rather than crunching somebody else's data. This is the Arecibo telescope from the aerial view. It's big. It's very big. It's 1,000 feet across. It's not. The only way to steer it, the only way to look at different parts of the sky with it, is by moving the feed horn. You can't move the dish because it's anchored to the ground. But it's in an ideal place. It's in between a couple of in very hilly country that tends to shield it from getting any kind of terrestrial interference from like your neighbor's microwave oven or something like that. How to join us? Well, you can download SETI at Home. That's free. You can join the SETI League. That's not free. But I will pass around some of these cards, and if you can just take some of those and send them around, and we'll take some of these and put them on the other side. Thank you. You can take one of these, and you can pass them back, please. And Joe.
Hey.
Hey. Could you take these?
Huh?
Could you take these?
Oh, yeah.
Take one and pass them around.
Oh, okay, great.
All right. These are extraterrestrial QSL cards from the SETI League. They're not filled out because you haven't made contact with the SETI League or you haven't found aliens for us yet. So once you do that, you can get one that's filled out. All right. There's a lot of ongoing SETI projects going on. SETI at Home is just one of them. The SETI League is just another one of them. So when somebody says SETI, they're not talking about any one particular organization. They're talking about a lot of organizations. So we have SETI League, SETI at Home. There's also the SETI Institute, Breakthrough Listen, and there's a lot of other programs that you can look at. On these cards that I've sent around, and I know I'm running over time, on these cards I'm sending around is the SETI League website, and there's a lot more information at that website besides what I can possibly cram into just 45 minutes here. So I'm going to end it here, and I'm going to take any questions that you might have, and see if anyone has any questions. In that?
A couple of big perspectives there, actually, the Iridium satellites and Mars. The supernova frequencies that are done at.
That one? Yeah. That I don't know. I have to get back. It's probably 1420 because he was doing the same thing I was doing.
How about the Mars surveyor?
Mars Surveyor would have probably been somewhere up around, I'm guessing 3 gigahertz, somewhere in that region.
What equipment did you use for that? Your dish, for example? Or
Say that again?
what equipment did you use to receive that?
When I was detecting these, I was using the IC 7000. That was the back end, and then I had an LNA that was available from through the SETI League. They made arrangements through a local dealer that actually built the LNAs for us, and that was tuned to 1420 megahertz. Right here.
Just food for thought. I'm very interested in this, but I thought, what is the possibility that life out there? We're looking on the electromagnetic spectrum. What about means of like, telepathy and other things, quantum physics? That they may be communicating. We may be looking through the electromagnetic spectrum, like banging pipes on to somebody who is very advanced.
Absolutely.
And I wonder about that sometimes because we've searched so much and we're not finding if there are other forms, and we don't have the technology for the quantum, physics that we need to know now. But I think maybe a lot of research needs to be done other than just the electromagnetic spectrum.
Okay. So that's all. Those are all very, very good points. And the thing is that you're right. We should be looking. We would like to be able to look at other places using other frequencies, other methods, maybe lasers. Lasers is a big thing now because lasers can
Prayer, telepathy. There's words for different things. I don't mean to be religious. Say that.
No, I know. I understand that. The thing about SETI is just like amateur radio. There's something for everyone. So anyone can conduct the search. There's also a search called SETI looking for artifacts from civilizations.
And there's got to be some that aren't that far advanced that are still using electromagnetic.
Yeah.
So it was just food for thought. I'm thinking there's got to be other.
No, you're exactly right. Now the SETI League focuses on the microwave search, but there are a lot of other projects that you can become part of or you can read up on that are doing not the telepathy, but the other things like the laser searching for artifacts, because there was a scientist named Freeman Dyson who proposed that civilizations could build a shell around their home star, thereby using all the energy from their star, and it was called a Dyson sphere. It was hypothesized that those Dyson spheres would emit infrared radiation. So if you looked in a part of the sky where there wasn't a star, but you could detect infrared radiation, that might be an indication that there was a Dyson sphere there. And we actually had a candidate for that.
We're about there. So
the SETI is such a large, broad subject that it's impossible to cover the whole gamut of what we do. So if you're at all interested in this, please go to the website on these cards and read through the website, go through the website, but especially also pay attention to the sources, the citations at the end of the website, because it'll direct you to other places that you can also investigate. I want to thank you all for having me tonight. Thank you very much.